Well, welcome everybody. Thank you very much for being with us this morning, this evening, wherever you might be. And it is the 24th of June. My goodness, how time is flying. We're here at LabLogic Innovators, which is a joint presentation of Awesome Numbers, LabVine, Elevate QC, and now M.O.R.E Quality. So we're getting more supporters as time goes on. Our mission is to create a measurable reduction in lab errors. And in order to do that, the first thing we have to do is measure those lab errors. It's an exclusive group, not terribly exclusive. We welcome most people, but it's a very informal working group to advance lab quality and risk management through the critical analysis of QC and risk management practices. We sit back and say, is this really what we should be doing? Can we do better? Our aim is to establish improved policies to improve lab efficiency. We want to save you time and energy within the lab. And most importantly, we want to ensure quality results that reduce lab errors and thus patient risk. Our plans for today, first of all, is a session with two components. You cannot judge quality with only a QC chart. We're going to look at 6 different scenarios where the same QC chart may represent good or bad analytical processes, and see how your choices of the QC chart, mean, and SD rules determine if those QC rules will detect failure in one run. We're going to take a quick look at discovering risk metrics hidden behind your statistical indicators, making that transition from statistical QC to clinical risk management. Today, we've budgeted 15 minutes at the end for Q&A. I hope you brought some Q's because I've got some A's, and I seeded it with a few, of course. And we have a bonus of a simple tool to evaluate the effectiveness of your QC charts in mere seconds. So we want to first look at QC differently. How many patients are you willing to send over the cliff of extreme risk? What if we taught quality control this way? Instead of statistics where people's eyes glaze over and just walk out saying, I don't understand statistics. We've got to impress upon them that these are people that they're managing. And depending on how far your Gaussian curve goes over the allowable error limit, you are sending people over the cliff of extreme risk. And it's just a more interesting and meaningful way to look at it. Michael said the other day, your cliff of extreme risk is giving me nightmares. I said, good. That is exactly what it's intended to do. Think about patients, not statistics. I want to share a poem to start you off today. It was written in 1895, and it's very applicable to us a decade and a half later. 'Twas a dangerous cliff, as they freely confessed, though to walk near its crest was so pleasant. But over its terrible edge there had slipped a duke and full many a peasant. So the people said something would have to be done, but their answers did not at all tally. Some said, put a fence round the edge of the cliff, some an ambulance down in the valley. But the cry for the ambulance carried the day, for it spread through the neighboring city. A fence may be useful or not, it is true, but each heart became brimful of pity for those who slipped over that dangerous cliff, and the dwellers in highway and alley gave pounds or gave pence, not to put up a fence, but an ambulance down in the valley. For the cliff is all right if you're careful, they said, and if folks even slipping or dropping, it isn't the slip that hurts them so much as the shot down below when they're stopping. So day after day, as these mishaps occurred, quick forth would these rescuers sally to pick up the victims who fell off the cliff with their ambulance down in the valley. Then an old sage remarked, it's a marvel to me that people give far more attention to repairing results than to stopping the cause when they'd much better aim at prevention. Let us stop at its source all this mischief, cried he. Come, neighbors and friends, let us rally. If the cliff we will fence, we might almost dispense with the ambulance down in the valley. Oh, he's a fanatic, the others rejoined. Dispense with the ambulance? Never. He'd dispense with all charities, too, if he could. No, we'll support them forever. Aren't we picking up folks just as fast as they fall? And shall this man dictate to us, shall he? Why should people of sense stop to put up a fence while the ambulance works in the valley? But a sensible few, who are practical too, will not bear with such nonsense much longer. They believe that prevention is better than cure, and their party will soon be the stronger. Encourage them then with your purse, voice, and pen, and while other philanthropists dally, they will scorn all pretense and put up a stout fence on the cliff that hangs over the valley. Better guide well the young than reclaim them when old, for the voice of true wisdom is calling. To rescue the fallen is good, but 'tis best to prevent other people from falling. Better close up the source of temptation and crime than deliver from dungeon or galley. Better put a strong fence round the top of the cliff than an ambulance down in the valley. I hope you enjoyed that, and I hope you saw the analogies to the people we're sending over the cliff of extreme risk and the benefits of preventing errors with risk management instead of detecting them with statistical quality control. So let me ask you, do you evaluate analytical method quality each month to determine the number of patients you are allowing to fall over the cliff of extreme risk? And I want you to answer in the chat, just 1 yes, 2 no, 3 question mark, whatever it is. Can sigma metrics tell you this? And is this metric important to manage risk, the number of patients you're exposing to risk? I'm going to see if I can be clever enough today to come over here and see the chats. Okay. No. I've got 1 no. Are there more people here? We've got some more people. Please do answer. You know, the point of this measure, of this meeting, is that we talk. It's not a webinar. It's not a lecture. It's a conversation. So please feel free to speak. So some of you do, some of you don't. Let me go back to my presentation here. And can sigma metrics tell you this? Can sigma tell you the number of patients you're exposing to risk? And is it important to know the number of patients? Are the other questions. So if you don't want to answer in the chat, at least think about these. If you're measuring sigma, do you think you're effectively monitoring the number of patients at risk? If you were here last month, you saw this, that sigma, in fact, is an inferior metric to the actual number of errors reported each year. Sigma does not take into account the number of patients that you measure every day. Sigma is reported in errors per million. If you report 100 patients a day, it will take you 27 years to get to 1 million patient results. If anybody was saying, what's the best metric to measure patient risk, I don't think anyone would come up with how many errors there are every 27 years. We adopted this from Sigma, from Sigma. We adopted Six Sigma from manufacturing, where they produce millions and millions of things every year. But we don't do that in labs. So let's look for metrics that are meaningful to medical lab management and patient care. An incorrect result, the edge of the cliff, is a result that does not meet the requirements for its intended medical use. In the case of a quantitative test, it's a result with a failure of measurement that exceeds a limit based on medical utility. That is from CLSI. So very clearly, your purpose is not to measure statistics, it's to measure medical acceptability of the results that you're turning out. ISO says that lab management shall establish, implement, and maintain processes for identifying risk of harm to patients and opportunities for improved patient care associated with its examinations and activities. You should be able to say, I did this for my QC process or my risk management process, and by doing that, I prevented X number of errors. And you need to develop actions to address both risks and opportunities for improvement. They're very clear on what you should do. They're not nearly as clear on how you can do that. And that's what we want to talk about today. So let's look at 6 different scenarios where the same QC chart might represent a good or a bad analytical process. I put this QC chart up on LinkedIn with the question, is this a good method? And some people said yes, and some people said no. And the true answer is it could be either one. What you might be missing if you're only looking at the QC chart, and I know a lot of people only verify or evaluate the quality of the analytical process by looking at their QC charts and saying if there's no QC flags, the method is okay. One of the things that you're missing is that the same distribution is expected on the QC chart and the Gaussian curve. So if you take this chart and stand it on its head, what you have is the Gaussian curve, where you were taught many years ago that 68% will fall within plus or minus 1 SD, 95% within plus or minus 2 SD, and very few will fall outside that 2 SD, and 99.7% will fall within plus or minus 3 SD. You need 5 risk drivers to measure method quality. You need to know the measured mean, the measured SD, the true value, the performance standard, the allowable limit of the total allowable error or the analytical performance standard, and the current acceptable risk level. If you're monitoring quality with only a QC chart, you don't have any of the information that you need to do that. So let's look at 6 different scenarios where the same QC chart might represent a good or a bad method. This is that QC chart we were looking at where the measured mean is 100 and the measured SD is 1. In this first scenario, the true value is 100 and the allowable error limit is 4. The sigma is the allowable error limit minus the bias, 4 minus 0, divided by the SD. So the sigma value is 4. If you were to shift, what that means when you know that the sigma value is 4, is that if this mean shifted 4 standard deviations, 50% of your patients would fall over the cliff of extreme risk. 50% of your patients would be exposed to unacceptable risk if you shifted by the full sigma metric. The question is, how many SDs can you shift? And that's not one that's commonly answered. If sigma is 4, what size of a shift in the mean do you need to detect before patient risk becomes unacceptable? Would you like to answer that in the chat? And let me go on to the next thing. No, it doesn't give us a hint. Let me give you a hint. If you think that a sigma of 3 is acceptable, you can only shift by 1 standard deviation. If you think a shift of a sigma of 5%, an allowable error of 5%, a sigma of 1.65 is acceptable, then you could shift by 2.36 or 2.35 standard deviations. Let's look at some different scenarios here. We'll get back to that conversation a little bit later. If you have a true value of 102, so we still have the same QC results. In all of these cases, the mean is 100 and the SD is 1. But if the true is 102 and the TEA is still 4, then your sigma is only 2. If your true value is 98 and the allowable error is 4, then your sigma is 2. This is to the lower allowable error limit. This is to the higher allowable error limit. When you look at the sigma metrics from these, you think they're both the same. If you don't see the image, you don't realize that this one has a negative bias and the one below has a positive bias. If, on the other hand, the allowable error limit is 2, then, your sigma value again is 2. It's the allowable error minus, the bias, of 0 divided by 1 is 2. So there's a mistake on that one. And on this one, that should be a 0. That's what happens when you keep working on things until the last minute. Look at the image, not the words. This gives you a sigma metric of 2. If, on the other hand, your allowable error limit is 8 instead of 2, then you've got a sigma metric of 8. In both of these cases, your QC chart looks identical. In this situation, now I have, just ignore these guys, or ignore this one in this case. I have a true value of 96, a TEA of 8, my mean is 100, my SD is 1, I've got a sigma metric of 4. What I would like you to answer in the chat is, should the risk distribution graph be part of your routine monthly QC review report? Answer yes, no, or maybe if you are putting question marks if you're not sure. But would it be helpful to see this image and get the correct values over here as part of your routine QC review? I would like to see that, and one day we'll give you the opportunity to see that as part of your peer comparison report. But right now, peer comparison reports compare you to what the rest of the group is doing. So if you're using a poor analytical process and everybody else, then you compare yourself to everybody else using that poor analytical process, you feel warm and comfy. But if you're comparing yourself to a good analytical process, or to a good analytical process, or to the acceptable medical criteria, then you get a very different image than just comparing to the peer. Sherry, what kind of answers did we get in the chat? Do people think that should be a part of the routine monthly review?
Overwhelming, yes.
Thank you. And I would add my yes to that. So the next thing we're going to do is look at how your choices of the QC chart mean and SD and the QC rules determine if Westgard rules will detect failure in one run. You control the QC process. You decide in the lab what's the mean value, what's the SD that you're going to put on the QC chart, what QC rules are you going to use, and how you make those decisions in your lab determines whether or not you will detect error if your method shifts from good to bad. You need 8 metrics, and perhaps 9, that will drive effectiveness of the QC chart to detect failure. You need to know the measured mean in SD, the true value, the performance standard. That's why I said 8. You don't need the current acceptable risk level. You need the potential acceptable risk level, which is how many errors am I willing to report for my daily QC. Your current acceptable risk level, you might say, I want to report no more than 1 error per year. And then you would say, if that rises to 1 error per day, I want to get a QC flag immediately. Why do I say 1 error per day? Well, if there's not 1 error, it's pretty hard to detect it. However, if you look at what has been done since Westard published his rules in about 1981, we've been accepting a 5% failure rate. And that's statistically meaningful, but it's not clinically acceptable. I don't want to report, if I'm testing 100 patients a day, I don't want to report 5 errors if I can get away with only reporting 1 error per day. And we're going to see that that is indeed attainable. You need to know the chart mean, you need to know the chart SD, and you need to know the QC reject rules. Whenever you run QC, you have 4 possibilities. This is your typical 2x2 table or 4x4 table, whatever you want to call it. You have a QC flag or you don't have a QC flag. The risk is acceptable or the risk is unacceptable. The vast majority of the QC that you perform falls into the category of a true negative. Most days there's nothing wrong and you do not get a QC flag. Occasionally, something goes wrong, and that's when you expect and trust your QC to detect that error, and that's a true positive. You're not as happy because you've got a positive. You've got to determine what went wrong, you've got to repeat your patients, you've got to fix the problem, but you're darn well satisfied because you got a QC flag when there was a problem. What you really want to worry about are the false positives. You get a QC flag and there's nothing wrong. You go through, you investigate, you waste time, and there's really, the risk is acceptable. There's nothing wrong with the method. It's just how you've defined your QC system that is causing you these QC flags. We've seen labs with as over 9% QC flags. That's ridiculous. And what it does is it's the little boy who cries wolf. You become blind to all of those QC flags and you learn to ignore them. And that puts you at risk of the false negative, where either you've ignored your QC flag or the risk is unacceptable and there is no QC flag. So you want to avoid the false positive, you want to avoid the false negative. So let's go back and ask that question that I started to ask earlier. If sigma is equals 4, what size of a shift in the mean do you want to detect before patient risk becomes unacceptable? Let's get people to answer that one in the chat. What size of a shift would you like to detect? Your sigma is 4 to begin with. Do you want it to detect a shift of 1 SD if sigma shifts from 4 to 3? Sherry, let me know if we're getting any answers, if people are just sitting there scratching their head.
All right. Well, and maybe say, can you guys answer? Or are you wondering, do you need more information?
Just put in a question mark or...
Yeah, because Ruvimbo needs more information. And I'm sorry if I mispronounce anybody's name.
Okay.
So you're saying what size of a shift in mean do you need? And Gift says question mark too. So guys, where exactly is the disconnect, do you think, with Zoe's idea here of, when you want to detect when risk is unacceptable, is that just a foreign idea to you? Are you needing more of a basic understanding of where she's coming from?
You want to open your mics and talk or put something in the chat?
Yeah, definitely. You can't talk.
Can't talk? Okay, put it in the chat.
Well, I'm saying people are free to unmute and ask and without having to type it.
Okay, cool. Can talk. Okay.
Yeah.
Okay. Let me carry on a little bit further and see if it becomes clearer. Do you think 3 sigma is a defensible, acceptable risk level? You read a lot of the literature, become common practice over the years to say 3 sigma is acceptable in labs. Now, the concept of 6 sigma came from manufacturing, where they said, we want to be 6 sigma. When we brought it over to labs, we being not me, it became common practice to say, oh, well, labs tend to get about 3 sigma, so we're going to say 3 sigma is acceptable for labs. But is that a defensible, acceptable risk level? Is there any science behind the concept that 3 sigma is acceptable for labs? Is one question. And I've not seen any. If you have, please raise your hand. And do you think, and if 3 sigma is what you're going to detect, if you say, I don't want my method to ever fall below 3 sigma, then I'm 4 sigma now, I drop to 3, I want to see a QC flag. Will this chart do that? Will any chart do that? So let me carry on a little bit here.
Gift said she's not sure when you ask about whether 3 sigma is a defensible, acceptable risk level.
Exactly. I do not. I've been studying sigma values or their predecessor, which was a better metric, the critical systematic error or critical systematic error since about 1990. And most methods have a sigma above 6. Why we started saying 3 sigma is acceptable in labs, I do not know. And I've seen recently publications that say 2.35 sigma is acceptable because you're only going to fail CLIA if 1 sample in 5 fails. So I'm willing to report 20% error and I'll still pass CLIA. We're not here to pass CLIA. We're here to manage patient care. And it's absolutely appalling to me that there have been recent publications saying that you can accept a 2.35 sigma. That's absolutely ludicrous that labs are willing to report 1 bad result in every 5 for patients. Because if a patient gets a bad result, they're either going to receive treatment they don't need, they're going to have to come back for tests they don't need, they're going to go for more expensive tests, or more importantly, they're going to miss a diagnosis. You're fine, today, and then you come back a year later, wow, will you look at that parathyroid tumor? I'm surprised your calcium was normal a year ago. Well, it wasn't normal. You sent out a bad result.
All right, I got a question for you.
Sure.
Ravimbo asking, we haven't really used sigmas over this side, so I guess that's where the confusion is. Does it translate to SD on the QC chart? Is 3 sigma plus or minus 3 SD?
No. Very good question.
Sean agrees.
Yeah, okay. Sigma is how far the mean can move until you hit the allowable error limit. Your plus or minus 3SD on the QC chart is what they call a standard deviation index. And that's how far that result is from the measured mean. Boy, I had some charts for this, but I'm afraid I can't find them quickly enough for you. But the sigma value is the number of standard deviations between the measured mean and the allowable error limit. Let me just go back a little bit here because I can show you. Yes. Okay, if you're looking at this chart, the sigma value is the number of standard deviations between the 100 and the 104 or the 96. So sigma is the number of standard deviations between the measured mean and the closest allowable error limit. The SDI on the QC chart tells you how far each individual point is from the measured mean. So if a point fell here, are you seeing my mouse, Sherry? Do you see my mouse move?
Yes, we can see your mouse. Yes.
Excellent. So if a point fell here, that's an SDI of 1. So that would show at +1 on the QC chart. If it fell down here, it would be about -1.5 on the QC chart. If it fell out here, it would be +3 on the QC chart. So the QC chart is this curve turned on its head, or turned on its side, rather. So the same distribution is here and here. Your QC chart only typically shows you the measured mean plus or minus 4 standard deviations, which by coincidence is exactly what this one shows you. The sigma is the number of SD the mean can move before it reaches the allowable error limit, and 50% of your results fail. It's a pretty ridiculous metric, in my humble opinion. Did that answer the question?
What do you think, guys? Are you up with us with where she's going on this chart right here?
So this chart, you're using SDIs. This is the standard deviation index. And on this chart, you've doubled your standard deviation. So where the measured mean, or the measured SD, pardon me, the measured SD is 1, the chart SD is 2. So you've drawn a line here, or they've drawn a line here, and I'll stop blaming you, at what they think is 2SD. But in fact, because they've doubled the standard deviation, it's actually, a point would have to be 4 standard deviations away from the measured mean to hit what you're calling a 2SD limit. This goes back to early 1991 when I went down to meet James Westgard. And we were walking across the parking lot into the hospital, and I said, what we do is we put the SD limits from our proficiency program on the QC chart. What do you think of that? And he said, I think it's dangerous. And I still remember my jaw bouncing off the pavement because I did not want to be and did not think I was doing anything that Westgard would think was dangerous. If you're doubling your standard deviation, and what he said to me was, you might be using a 1/6S rule, and nobody knows the error detection capability of a 1/6S rule. I'm going to get out of order here again, and I'm going to show you this. These are the actual rules these people are using. These are 4 lab instruments. They think they're using a 1/2S rule. The only time they're really using a 1/2S rule, the blue dots are their positive rules, the orange dots are their negative rules. They very seldom, and they often assign their means incorrectly. So what they think is a -2SD might be right on the mean because they've set they put the mean on the QC chart 2 SDs higher than it is, and then they've doubled the standard deviation. It's not uncommon to see people using a 1/6S rule or a -6S rule or a 1/10X rule. These are the rules that people are using, and that's why QC doesn't work the way it's being done today. It's not being taught properly is the problem. And that's because there simply isn't enough time in the average med tech education program to teach quality control properly. And you can pass your exams as a medical lab scientist or a medical technologist, at least in Canada, and I believe in North America. You might have 1 or 2 questions about quality control in chemistry. You might have 1 in hematology, and that's it. So you can pass as a medical lab technologist and never be qualified to do quality control. It's positively frightening, and it should change. There should be something done differently. And what needs to be done after years and years of trying to teach it, it's too complicated to teach in the time we have available. What you need to do, and what I've spent my lifetime doing, is develop software that does this properly. And in the 2 hours or 5 hours you get to train people, you can very effectively train them to use the software. The software says put these numbers here. It tells you you've got a problem with accuracy, you've got a problem with precision, you need to do these, you need to take this action or this action. This is the number of patients you're exposing to risk. If you do this, you will reduce it to your acceptable level. It's too complicated. You cannot manage risk with an Excel file. It's impossible. Once I upgraded from statistical QC to risk management, I needed to go to software. So it looks like what I'm using is Excel, but boy, this is Excel on steroids. And it's really being done in the software that's behind it. So we asked the question, can you detect? So if you thought that 3 sigma was acceptable, you could only shift 1 standard deviation. This is a shift of 1 standard deviation. You're not even going to notice it. If you put the real standard deviation on the QC chart, for one thing, using a 1-2S rule, you're going to pay the penalty of false positive flags because only 95% of results fall within plus or minus 2SD, 5% fall outside. So 1 in 40 will be outside on the high end, 1 in 40 will be outside on the low end. Even with the real mean in SD on the QC chart, you're not going to detect a shift of 1 SD. The information you don't have right now is, do I need to detect a shift of 1 SD? And that's the information you get from the software. So if you think that 5% is an acceptable error rate, and that's what Westgard has taught us, then you can shift 2.36 standard deviations. If you use your real mean in SD, yes, you will detect that shift. You'll get, out of this 15, you've only got 3 that are not flagged. So there's a good probability you'll see that shift in the first flag. Do you think 5% is a defensible, acceptable risk level? Yes, no, maybe. You know, it's statistical, 95% probability. That's what every statistician will teach you. That's what Westgard used back in the 70s and the 80s. But does it make sense today? And, you know, I'll give you a moment to answer, but you can kind of tell by my tone of voice, I'm not a big fan of it. I don't want to report more than 1 error. And the percent acceptable risk will vary. If I'm testing 1,000 patients a day, it's a very small percentage. If I'm testing 10 patients a day, it's a very big percentage. Everything that's been done until now has ignored the number of patients that you're testing. If we go back to that original chart with the inflated standard deviation, which is so very typical, even if you've got an okay, and now this one, I changed the total allowable error limit to 8. So if you've got a sigma value of 8, you can get away with doubling your SD. But you've got to know, really, what is the margin for error? How many SDs can this method shift before risk becomes unacceptable? And then you've got to say what CLSI says is, at the very least, you should evaluate the ability of your QC process to detect medically allowable error. Do you think that 1 MUR per day is a defensible and attainable acceptable risk level? And I'll give you a moment to answer that. Is it defensible? 1, is it attainable? 2, sure, it would be nice, but can we really do that? What we getting, Sherry?
holding for answers. Do you think one MUR a day is defensible and attainable risk level? Feel free to give us a thumbs up if you want to say yes. Feel free to give us a thumbs down. And Gift says yes, it is defensible and it is attainable.
Absolutely. And it
Ruben
is.
Mo says it could be.
Okay. Here's what happened with these labs. Now, I'm looking here at 3 QC samples in each one of these from each one of these instruments. So if this bar is at 3, because I designed it to detect 3 errors, so 1 error per day. If you're at the level of 3, your risk is acceptable. So you can see that it differs by analyte. It differs by instrument. Different instruments have different risk levels. Different months have different risk levels. And the important thing is this is the acceptable risk level. Very, very few QC processes, as they are performed today, are meeting an acceptable risk level of 1 error per day. And it is attainable. You simply have to put your real mean, your real SD on the QC chart and use the QC rules that we recommend, and when necessary, improve your analytical process. So these are the actual rules in use. They're all over the map. These are the rules that we would use. Sometimes it's a 2.5S, sometimes it's a 3S, sometimes it's a 3.5S. So at the high level here, it's a 3.5S. These dips are a 1.3S, and the lowest you ever go to is a 1.2.5S. With a 1.2.5S rule, you will never see a false positive flag unless the method, you won't unless the method changes, in which case it's a true positive flag. So by using a 1.2.5S rule and improving your method so that you can use a 1.2.5S rule, you eliminate false positives, which is everybody's greatest fear. We don't want to see the false positives. And you can detect failure of 1 error per day should that failure occur. This is a different lab. And again, they were aiming for a 1.3S rule, and they're up to over a 1.10S rule. Discover the risk metrics hidden behind your statistical indicators. I want to talk to you about a process that I call more quality, mathematically optimized risk evaluation. And this process is enabled by Elevate QC, the Elevate QC platform. More quality is a risk management process enabled by software and enhanced with curated AI. Curated AI. Don't believe AI unless somebody has been through and said, oh yes, it's telling you the truth. So Elevate QC is dedicated to changing the process of risk management and improving patient care. It's based on an award-winning algorithm combined with an AI-augmented knowledge base. It will assess your current control practices. It means fewer errors and more accurate blood tests. It matters because patients matter. Trustworthy and accurate blood tests help doctors and patients. That's what we're here for. Designing effective risk management processes without verified software is like trying to pick a lock with a limp spaghetti noodle. You just can't do it. There are some things you cannot do without the right equipment. My eldest son is a Red Seal mechanic. He is taught that when the machine gives this error message, go to the manual and look up what it means. Follow the computer. That's what we need to teach lab techs. We should not have every Tom, Dick, and Harry designing their own QC process. At this rate, we'll detect that shift just in time for retirement. EQC detects failure of acceptable risk and guides improvement action. This is reality. This is a shift in the mean in total protein that took this out of clinical acceptability. And if the same thing happened at the low end, we provide you a report with AI that says, if this happened to a patient you were monitoring, here's what the doctor would think differently. Here's what the doctor would do differently. It took them the better part of a month before they happened to put in a new reagent lot and fix the program. If they were using this software properly, they would have fixed this problem and never accepted this period when they were out of control. I'm not going to read this to you. If you would like to receive this list, this is just an example of the risk metric or risk driver. Does it come from opinion or fact? And what does it tell you? Where you are, where you want to be, or where you expect to be. The acceptable risk level is what's new. The margin for error is the number of SDs you can shift, not to the allowable error limit, but until risk becomes unacceptable. And then the number of medically unreliable results per year is another new metric. So put a yes in the chat if you'd like to receive this list with a little bit more information. Okay, Q&A. I'm going to go through just this first and hopefully have a few minutes for you guys at the end. How can I project the potential reduction in medically unreliable results in my lab? How can I tell if my QC charts are effective? How much time and effort does it take to upgrade SQC to clinical risk management? What we're offering you to do and inviting you to do is discover your risk metrics and opportunities for improvement with Elevate QC's First Look program. You send us QC data and QC charts for these 20 analytes. Just send the chart, send the reports, export a report from your LIS, your EHR, your QC platform, and answer a few questions. We answer these questions right in your 30-minute meeting, and then you complete 80% of that when we have our first meeting. You go home and look up, here's my true value, here's the number of patients per day that I test. Everything else is completed in under 10 minutes at that meeting. We did one yesterday. We've got the data in today. She could have her results back in a couple of days. We tell you for each analyte how many preventable MURs per year you have, 0, 1 to 10, 11 to 100, or up to over 1,000. And you can see that it changes by month, and it changes by analyte, and it changes by instrument. You can't do this with an Excel file. These are all preventable with advice from EQC. All you need to do is complete the file. We're including thyroid tests in here, and some people call that special chemistry or whatever. Tell us the average number of patient samples per day. Provide the true value for each QC sample. Provide printouts of all data points and, if possible, QC charts in any file format you like. The date range defaults to 4 weeks, beginning 2 days after your meeting. And that's as simple as it is. It takes you half an hour, and you'll find out how many medically unreliable results you can avoid per year and per QC failure. Would you like to book a 30-minute online meeting to know more about the First Look program and complete over 80% of the information required? And I'll give you a moment to answer in chat, yes, no, or maybe.
What I've done too is I've given the link to the First Look booking. So feel free to click that and get registered for that. It is outside of LabLogic Innovators, but it will give you a chance to have your data reviewed. And it's about a 30 to 45 minute meeting. And then Zoe does walk through the SOP for getting the information back to us that we need. So Hassan says, thanks for sharing. And Ravimbo says, yes.
Perfect.
And,
Okay.
and like I say, the link is there in the chat. You can click on it and it'll open a page so that you can see a little bit more information and a calendar. You can choose a time that works for you.
Excellent. So if you want to think about it, look at your calendar. Sherry, you'll probably be sending out a follow-up email with the link to this recording.
Yes,
And
and
I'm
the
sure that
list.
and the information there where you can book that first look.
Yeah.
So this is exciting. This is brand new. We're doing our very first one. We had the meeting yesterday. The data are here today. We'll be crunching data by tomorrow. We'll be doing it today, except I have to go out for a while. Anybody else got more questions?
Yeah. And feel
More
free
questions.
to open your mic and ask a question if you need it. It would help if Zoe hears where you're at and what you'd like to know more about. Questions. Da, 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 da.
In order to innovate, we are LabLogic Innovators. We need your input. We need your data. When you complete these studies like this, it gives us the information to publish, to say, here's what you're doing with statistical QC. Here's the million sigma studies you've seen published online. Here's what that means. People publish sigma studies and they publish, analytes with a sigma below 2, and they don't say, oh my God, you're reporting 10% or 15% errors. We're not connecting the statistics to the people. And that's why I invented the cliff of extreme risk and show you heads rolling down the hill. Start thinking about people.
Where would a person go to get an in-depth look into sigma and how it's being used to assess risk? Like, I don't think sigma is being used to assess risk. It's more quality that's
some articles that claim that, but then the same people will tell you that 3 sigma is equivalent to a 6.7% error rate, and that's acceptable.
Is that true?
Oh God, no. I mean, both are not true. Pardon my language, but no, it's not true that 3 sigma is a 6.7% error rate. That's an assumption that came from manufacturing back in the 1980s, where in that industry, they saw a typical shift of 1.5 SD. So they said, if I get 3 sigma, if I get 4.5 sigma, that's actually 3 sigma. Or if I get 3 sigma, that's actually 1.5. So if you go to, i.e., the Westgard site and look up the error rate associated with 3 sigma, they'll tell you it's 67,000 per million, which is 6.7%, which is definitely not acceptable. You don't want to be in a lab. You don't want to go to a lab and have a 6.7% error probability of getting an error rate. Another good question, should we publish our error rates? Should patients know? I mean, we take your QC and we give it a grade based on the current risk and the potential risk. And we grade your methods from grade A to grade F. One of these days, I'm going to have time to write a book that says demand a grade A lab test.
That's what I've always thought. I should be able to go in and ask the lab where I'm getting my tests, what is your grade?
Exactly. You should be able to go in and ask. I went to a lab.
Let me ask you something. Let me interrupt you. I think we have a little bit of a disconnect here because Gift is saying I need more knowledge and information about Six Sigma because it's not commonly used in this part of the country yet. And I said, this is the point. Don't waste time on Sigma. You don't want a more in-depth knowledge about Six Sigma unless you like learning things that are super outdated and don't really work.
Exactly. Do not learn about Six Sigma. Come to us. I am working on courses to learn more about risk management.
Yeah.
Six Sigma does not belong in the lab.
I think you have a poster that we could also share that talks about Six Sigma versus risk, the M.O.R.E quality idea, right?
I do have a poster on more quality. I have a poster saying that the formula that Dr. Westgard uses to calculate sigma is incorrect. But I don't have that specific one. And I wish I had a clone,
Oh, well, I
because
think
we
we had one. I think we had one last year that had to do with the ways in which Six Sigma is not working.
okay.
I think so. You guys, I will definitely look into that. I'll get you some links. Don't be scared to open our email when you get it, because it's coming out of a MailChimp. So it's an acceptable, safe platform, and the links will bring you back to the website where I've got the PDFs posted and things like that. But we'll get those posters to you, because Zoe has posters every year at the ADLM, used to be AACC, and she's won awards for her posters and her, the thought process that she's bringing to this industry. We're going to be able to revolutionize what you do, instead of you having to be stuck in the old ideas, which are being shown to be wrong and not accurate and could be safer. How about that? Who cares if they're wrong? Let's make it more right. That's what we're trying to do. This 7 scenarios of QC strategies that she's showing you right now, this is part of the poster that she did. Yeah.
This is the award-winning poster that said, if you follow Westgard recommendations and calculate sigma, this lab was testing 30,000 QC samples a year and exposing 40,000 patients to risk. If they implemented Westgard rules based on sigma values, it made no difference to the patient risk. If they increased the frequency based on what Westgard was recommending based on sigma, it doubled their QC volume, but it did nothing for their patient risk. If you follow our processes and put the right mean and the right SD on the QC chart, you'll cut your number of errors in half. If you follow our software to improve your analytical process where necessary, you will cut your errors in half again. And even with all that, Westgard will never recommend less than a 1.3S rule. And there are times that a 1.3S rule will simply not detect the size of shift you need to detect. So you can use better rules. So with all due respect to Dr. Westgard, he did it first, but we do it better. This process with our software will report far fewer errors. So this is what you were doing with Westgard's recommendation, exposing 40,000 patients to risk. With ours, you're down to about 3. And if you want to bracket your QC, you can reduce it to 0. We have a better process than Six Sigma and Westgard rules.
And it's not a separate process. It's a process that layers on top of whatever you're doing for quality control now. Is that not right?
Exactly. You don't need to substitute the QC that you're doing. What we do is we tell you, put this mean, put this SD on the QC chart, use these rules. This method needs to improve accuracy. This method needs to improve precision. Here's the things that you should do to make that happen.
All right, watch this. She says, by putting the right mean, quote unquote, into your QC chart, is it the manufacturer provided one, or are we missing something?
You are missing something, and bless your heart for asking. The purpose of the quality control chart is to tell you when the method changes. That is the only thing a quality control chart could do. Back in the 90s, Westgard taught that. The only thing that your QC chart can do is say, excuse me, your method changed. The entire purpose of a QC chart is to tell you if the mean or SD has changed. If you put the mean and SD from last month on the QC chart and it changes, then you want to say, was that change significant? Was it for the better or for the worse? Was it acceptable or unacceptable? Those are the questions that we answer for you in minutes. We talked to somebody yesterday. They just spent, their staff had spent 4 hours trying to solve a problem. We said, we could have cut that down to 5 minutes for you. When, if a QC flag occurs, use our software, our process, you'll cut that 4 hours of time wasted. Or you might just do oh, well, we know it was a reagent change, so we'll accept it. You can't just, if you know why the change occurred, say that's okay. So please do not go learn more about WestGuard. Do not go learn more about Sigma. We will develop those clear, concise comparisons of what's the difference and why you need to do, why this is better. It's time to upgrade from statistical QC to risk management. And this poster that won the award shows specifically this is what WestGuard would do, and this is what we would do. And this cuts your patients at risk from here down to here. I love Dr. WestGuard. I trained, he mentored me back in the 90s, but he hasn't moved on. And he and I did a workshop together in 1991 where he said, I like to develop concepts, and then I rely on people like Zoe to go ahead and develop them further. And that's exactly what I've been doing for the rest of my life, is I've been saying, well, this didn't really work. There's a better way to do this. There's a better way to do that. There's a better way to do that. And I just keep, and that's why it's taken so long to get the software out, is I keep making the darn stuff better. But we're at the point now that we've got it working. We're ready to offer you a first look. We're ready to show you what the software can show you. And if you do that first look program, invest 30 minutes, you'll see the difference.
We have
from whatever
labs.
You're doing now.
Yeah, we're at 11:01, Zoe. Does anybody have questions that you want to pose? If we leave this meeting, we are going to send you a recording, but you can also send your messages in. If you're in the LinkedIn group, you can discuss it in there. I highly recommend you get in there because Zoe does spend time every day in LinkedIn, and she would see your comments and questions and be able to answer you basically in real time. And then our next meeting is going to be the last Tuesday of July, which of course I can't see it because I'm full screen right now, but let me just see. In July, the last Tuesday is the 29th of July. So any questions you guys have, we need you to participate and come into the LinkedIn group for sure and get your questions up in there. And we may have some other things. We'll follow up with the list. We'll follow up with the links and the posters so we can help you understand how this deviates from Sigma. Asan wants to know, what's the best way to establish lab mean SD from manufactured mean SD?
You measure it. You take your data points and calculate it.
Okay.
Like here, you would take all the individual data points in here, and are you doing your software on a computer of some sort? I would take it, or in Excel even.
Son, you want to turn on your microphone and talk to Zoe about this?
Yeah.
Yes. We are counting 20 data points.
Yeah. And then just measure the mean and SD on those 20 data points.
But sometimes we are getting failed when we are shifting our lab mean, manufactured mean to our lab mean SD. Then QC is getting out of control.
Okay, so if you see a shift like this.
Yes.
Okay.
So what is the best way?
Are you getting QC flags?
We are using M.O.R.E software, Unity software.
Okay. What you would do then is you would go up here and you would ask the question. That's not a good example. Let's go to this one.
Okay.
In this one, say your mean shifted from here over to here, it would be perfectly acceptable and you could just reassign the mean. But if your mean was here 4 and then it shifted again up to, so your here your margin for error is getting very small. If your mean shifted further to the right there,
Yes.
then you would have to figure out what's going on and what it takes to fix it. See this guy here, okay? If you
Yes.
had a shift of 1 SD, you might get QC flags depending on how you've set up your QC chart. You might go in and you would say, okay, I'm going to fool around a little bit here and I'm going to make this 8 to start with, and I'm going to take this guy away. So say your sigma value was 8 to begin with. If you shifted 2 SD, you're still fine. You'll get flags. But then if you were here and you shifted another 2 SD, now you're getting people over the edge. You've got to say, oh, what did I do here? Did I recalibrate? Maybe that calibration is not acceptable. We have and we provide our clients with a standard operating procedure for when you put in a new reagent lot, or when you do a recalibration, or when you just see a shift in the mean and you don't know why. You test your QC 4 times and you ask the software, is the new mean, so you take the mean of those 4 data points, you put it into the software and say, is that still acceptable? And it will tell you yes or no. If it is acceptable, you just need to change the mean, the SD, and the rules on your QC chart. If they change, like you would go with your usual standard deviation. Did that make sense? Like if the mean shifts, you would assume that the SD stayed the same. So if I was up here and I shifted all the way down here, I would definitely see QC flags because the mean had shifted, but it's still acceptable. If I was here and I shifted down to here, that is not acceptable. And that's where you've got to get off of the QC chart, say, what is my margin for error and how many patients am I reporting at risk? And that's what this software will tell you. So if you saw that shift and it's not acceptable, now, one of the things you can do if you're using the Unity program, you can go in and say, well, did everybody shift? If the whole peer group shifted, then there's something wrong with the reagent. You ask Bio-Rad or you ask your reagent manufacturer to solve the problem.
Should we change SD as well, or both? Mean or SD? From manufactured to lab mean SD.
Do you set allowable error limits?
Yes?
Okay. Do you measure total error then?
No.
No.
Actually,
What?
we don't know too much.
Okay.
Yes.
Are you mistaking allowable error limits for QC chart limits?
We're only checking this Westergaard rules.
Okay. And that's what you're missing if you're not looking,
Yes.
at this, is my method acceptable?
Yes.
Okay. What you're seeing on your QC chart,
Yes.
the data that you see will always have this normal Gaussian distribution.
Yes.
So if you see a shift in the mean, he'll pop up to here, and you're going to start to get QC flags. You need to go back and ask, okay, where is that relative to, like you can use CLIA limits. Your best thing to do is to say, and what I did when I sound like I'm a million years old. I started this before CLIA was invented. I sat down with my medical director and said, for this analyte at this level, how far can the value shift before the doctor's going to react differently? So say you've got a sodium and your QC sample is running at 140, at 100 and 138. Ask yourself,
Yes.
if I report 137, is the doctor going to do anything differently? How about 136, 135, 134? Usually about 134, people start to squirm. And you say, yeah, the doctor's going to react differently. One thing we can help you with, let me come over here, is what would a clinician think and do if a patient being monitored for total protein dropped from 5.1 to 4.7? And you can ask AI to give you some of these allowable error limits, or we can work on developing this. So here's what might happen for advanced liver disease and so on. But if that value dropped and it was 3 point, in this low level, it was a very different situation. So there's a lot, like, sign up for that first look and see what you see and the questions that you need answered, and learn to look at things looking at the Gaussian distribution, and then take this over to this view of it. And your allowable error limit is as simple as asking, how different can this be before the doctor's going to react differently? Do you have a medical lab director who's a clinical pathologist?
Yes.
Okay, sit down with that person and say,
Okay.
I'm doing a control for this test and I'm measuring it here. How far would
Yes.
the results have to be away from what I'm getting now before the doctor's going to react differently and do different things with the patient? That's the
Sure.
way to start. The second best way to start would be to look up the CLIA values, or if you've got, regulated limits where you are, if you're in an EQA program.
How many data points we should take?
I would use, like, when you're establishing your mean in SD, I would use 20 data points. But if you're looking for a shift in the mean, to validate a new reagent lot or a new
Is
calibration,
it compulsory we should establish our lab mean SD,
absolutely,
or we can go for manufacturer values?
absolutely, you must establish your own. Using the
Okay.
manufacturers is what gets you into this trouble down here where you don't see the shift in the mean. So if you're using the manufacturer's values on the QC chart, you're not going to see the shifts. The manufacturer will often set values that you can't miss, with a bushel basket, so to speak.
Okay.
So you have to set your own mean, you have to set your own SD, you have to select the right rules, and that's where we can help you. But you
Okay.
must put your own mean and SD on the QC chart.
So we should change both mean as well as SD.
Yes, but don't go into this blindly, please.
Oh, yes.
Work with us, because if the only thing you do is change the mean and SD on the QC chart, it will help.
Yes.
But you've also got to select the right rules, and sometimes you need to know when you need to improve the method.
Okay. Thank you.
Okay, so sign up for a first look and see how much we can help you with that. We've got a limited amount that we can sort of donate as far as help goes, but you'll
Okay.
also be helping us in knowing what people need to learn. And I want to, many things I want to do, but I want to create educational courses that will teach everybody that sort of thing.
Yes. Yes.
Okay.
Thanks for your guidance.
Okay, you're very welcome, and don't hesitate to reach out.
Yes. Yes.
You're providing good examples that other people will learn from.
Actually, we are not aware about these things. That's why.
If we can if we can prove how we can make things better in your lab, then eventually we can take that to whoever is paying for the lab tests. if we can say, we reduce the number of errors in your lab from X to a big, smaller Y, if the government is paying for health care in your country, if people are paying for it individually, if insurance companies are paying for it, if patients are paying for it, what we're recommending will improve patient care. And that's what this is all about. And if we can help you improve patient care, you can help us prove the value of this process. What I want to do is change how the world does quality.
Yes.
And by the way, the idea
All you're
here
doing
of
is
reducing the
insurance.
cost is it's going to pay for itself.
Yeah,
Yes.
yeah.
Right. Anybody
Oh,
else? We're at 11:15. We're about 15 minutes past the mark. If anybody, nobody dropped, so I'm really excited that you guys decided to stay. That was a really good talk, Hassan. Anybody else have a question before we go? Oh, Gift says it's making a lot of sense now. Thank you, Dr. Zoe.
oh, thank you so much. I'm glad to hear that. It takes a lot, and it takes a repetition, and it takes making, clearer and clearer examples.
Yeah,
We're getting there.
there you go. All
Okay,
right.
well,
Yep.
go ahead, Sherry.
Was there
Wrap her up.
anything you needed to wrap up there on your slides?
No, just a very big thank you to everybody.
All right. Well, guys, I'll make sure that I pester Zoe to give me the list and all the links that we need, and we'll get those posters where you can view them. And if you go to LabLogicInnovators.com and you go to the events page, you can go ahead and register for next month. I'll get it updated, and I will be sending out emails so that people will get registered. Chat in the LinkedIn group for sure, please, and definitely take advantage of that first look. And thank you, Haneen. It was so good that you could be with us today. Thank you, everybody, for being here. And thank you, John. And Zoe, if you have anything to sign off with, be my guest.
Okay, nope, just thank you so much, everybody. It really helps to have your participation in this. Come back next month, do book a first look, and chat with us in the LinkedIn group. So have a good day, and we'll see you next month.